So, just spent the first few minutes not realizing the mic was off. So now I'll just go ahead and repeat all the things that I said. Yeah, so I hope everyone had a good weekend. I hope that everyone had a good restful weekend. You might not have, because it was Cinco de Mayo weekend. I know a lot of people like to party. I got to go to the Baltimore Tattoo Convention this weekend. That was pretty cool. I'm probably good. I found some artists there, found some good ideas. I'm trying to finish off a left arm sleeve, so hopefully I'll get that done shortly. I'll show everybody my designs for that maybe before I actually get it done, get some feedback. But yeah, that was cool. I went out, hung out with some friends from the tech meetup that I attend around here. So we got to hang out, kind of do the whole Cinco de Mayo thing on Saturday. Sunday, just kind of chilled, got ready for Game of Thrones. That's my show. Did a little bit of work. Did a lot of work, actually. So Mastermind is the moniker that I use for this channel. But Mastermind is going to be something much bigger than just this Twitch channel. So I was working with a lot of things in regards to that. I'm actually in a business protege cohort right now where I, with a handful of other businesses, are working together to, really understand how to build a business, how to build a brand, and kind of work through that. So I've got a lot of other things in the works with this, which is why I've kind of been MIA a little bit for the past week or week and a half. I'm definitely going to try to make sure that is not the case any longer. I got a little hung up with all that stuff, as well as the work for my day job. So I am a DevOps engineer at a software company currently. I'm actually technical lead now, and that's been taking up a lot of my time as well. So definitely all good things, but finding a way to balance all that time has been pretty tough. So the streams have been getting the axe for the past week or so. I think I also didn't do one stream because I needed to go see Endgame, because I was worried about you all spoiling it on Facebook. So I did do that. That was good. So I'm glad I got to go see that. But what time is it? 7:37. Let's get started. So tonight, I want to talk about dive deeper into some programming topics. In the meetup that I helped host this past week, we actually went over a lot of these things. Went over kind of different programming languages, kind of what they're good for, and things like that. So I thought it would be a good idea to tonight talk about the different programming. We'll go over kind of the different programming languages, but the different programming language types. So we'll be going over, interpreted versus compiled languages. We'll be going over the concepts of static versus dynamic typing. And then we'll dive into some IDEs and text editors and talk about the differences between the two, and what you can start using to kind of start your own projects or start learning, depending on what languages you want to work with. And I think this will also be helpful in helping people get up to speed and being able to participate in the Monday Night Crucibles, where we are learning how to code and solve those problems on exorcism.io. But yeah, I really thought Endgame, so Endgame is what, 11 years in the making. I think I've seen all 22 movies. I actually had to finish up. I had to finish up Ant-Man and the Wasp, and I had to finish up Captain Marvel right before I went to go see it. So we did that the day before, and then we headed out to see Endgame, and it was worth it. It was worth it. I'm impressed to see how people can make this many movies, tie them all together in a nice, cohesive way, and I definitely was satisfied at the end of it, for sure. But cool, so we'll get started here. I actually didn't get to finish making this PowerPoint, so this PowerPoint only has the beginning piece of this, but we'll go through the rest. So to introduce myself, if you're new to the channel here, my name is Aaron Brooks. I'm a tech lead and DevOps engineer at a software company called Fearless, and you can find me at LinkedIn /in mastermind.io and on every other social media platform at mastermind.io. I'm only here to teach you guys what I know. I like to teach people this information. I like to just share the things I know. I think it's fun, and I like how tech can be life-changing for people. So it can be accessible to just about everyone. With a $50 Chromebook and some free Wi-Fi from McDonald's, you can go learn whatever you want. And I think tech is a cool thing to learn. Also, a little bit more about the channel. Mondays are usually coding coding focus, we are doing something. We usually do something called the Crucible, where we're trying to solve all of the problems on a website called exorcism.io. And what that is, I'll just pull it up really quick. Trying to solve all the, you can go to exorcism.io and sign up. There's a bunch of language tracks. There's like 100 problems on here. There's different number of problems for different languages, but we're trying to solve all of the problems on there. So that's what we usually do on Mondays is coding stuff and coding topics. And then on Wednesdays, we do something called Curated Cloud, which is more cloud concepts, more systems concepts. So we do things, we do like a Linux masterclass, which we're kind of still in, stuff AWS, Google Cloud Platform. So things, Docker, things dealing with systems, things dealing with the cloud, more DevOpsy type things are on Wednesdays. Also, you can send in a little chat command to get the YouTube channel. I don't have enough followers yet to have my own custom vanity URL. So it's a long string. So you can click on there to get to there. I will be posting videos specific for YouTube on YouTube. I'm working on a lot of those now. Also, these streams go up on YouTube afterwards. Thanks to ESB for the subscription, man. Appreciate that. So let's get started. So let's talk about interpreted versus compiled languages. Cool. So what does that mean? Let's go to the first one. So compiled languages. What is a compiled language? So compiled language, and again, there's a lot of words here, and I pulled this straight off the internet, but we're going to dive a lot deeper into what this is. But a compiled language is when a compiler produces a program written in an assembly language. The assembler of architecture then turns the resulting program into binary code. And actually, let me move my face so that you can see the entire thing. In the binary code, assembly language varies for each individual computer depending upon its architecture. Consequently, compiled programs can only run on computers that have the same architecture as the computer in which they were compiled on. Now, a lot of words right there, a whole lot of words right there. But let's break that down and figure out what that means. So, a compiler produces a program written in assembly language. So, when we write a program, we write it in language. So the compiled language of choice that you've seen on this channel already is Go. So Golang, programming language written by Google. This is a compiled language. One of probably the most popular one that everyone might know about is something called Java. There's also C, C++, things like that. But let me get out of here for a second and let's take a look at. Let me get logged back into my VM. Second. But if we go, actually let's break down the first piece. So let's take a look at some Go code, and let's go into the Crucible. So that's something we do. Again, that's the program we do on Mondays. Let's go into Go, and let's go into just this hello world in here, and let's take a look. Let's take a look at this. This a bit smaller so I can come back to it. All right, let's move my face back down here. All right, so the code that you write for Go, let's delete all this extra stuff. You write it in this relatively easy to read. You write it in this relatively easy to read language. We've got some words here. This is readable to you. And so basically what a compiled language does is it takes this code that you write that's designed to be easily written by a human. It's human readable. It takes it. You run it through a compiler, so there's another program, and it compiles it down to an assembly language. And then this assembly language, it changes depending on the architecture that you're on. But then that assembly language again boils that down into something called bytecode that can be read, that's machine readable, and that can be read from the thing that you are, the system that you're trying to run this on. So basically what happens is when I go to, Go is cool in that it's a compiled language that you can run like a what happened? Oh, I didn't give it you can run this like an interpreted language. In the background, it actually compiles. Let's break this really quick. Let's try to run this. We'll save this. Package main, func main. And see, these are some of the problems with, not problems, but these are some of the issues. So we're gonna this is some of the issues with a compiled language, in that they're a little more difficult to kind of get started with and write, because there's a little more structure that has to happen. But let's save that really quick. Let's see if we can get something out of here. Missing, return. What's happening here? Oh, cancel. Let's remove this. Not gonna return anything because the main function. Come on, this should work. All right, cool. So we've run a hello world thing in a compiled language. So what didn't happen here is you didn't see it go compile, but this when I ran this, it actually went to the background. It compiled my software, and it broke it down into, again, that assembly language and that bytecode that's made just for the system that I'm running on. And so usually for a Go program, you do something called Go build. And when I do Go build, it's not going to build. I need to go into another thing because of the way this project is set up. But if this was built properly, when I run Go build, it would compile my code. It would do a lot of things called type checking. It would do a bunch of stuff, and it would convert that into an executable that is made for my computer. And if I type in, let's clear this. Let's go back. Let's go back here. And if I do go env, I believe. All right. So the type of system I'm running on, this is a virtual machine. This is a Linux virtual machine, but it is of an AMD 64 architecture. So you're usually having a 32-bit, like an AMD 32 or AMD 64 architecture. If it's a newer computer, most servers will be this AMD 64, and this Go OS, so Linux. So because I have these things set on my computer, and this is, again, this part is specific to Go, but this targeting that I'm talking about, so the type of system it's going to be built for, that's called targeting, that's called building for a target, applies to all compiled languages. So Java, if you're writing in Java, you're writing in C, you will have to set things like this up. They're done in different ways, but when it gets built, it builds for an AMD 64 architecture and a Linux machine. Doesn't mean it can't, it may run successfully on other architectures, but it's specifically built for this right now. So if I were to run this through the compiler, it would do that and turn it into a non-human readable object or package for the computer. So because of this, because it takes the time to do this, compiled languages are actually very fast, or they're very fast. They're a lot faster than most interpreted languages, and this is because, again, it does that conversion down to bytecode into code that is basically machine readable, and then compiling does kind of all the things, all the checking, all of the crazy stuff that you think not that is important. It does all that up front. So the good thing about this is it's actually kind of nice. You write code, and when you go to compile it, it'll fail. Like if there's anything wrong, it will fail for you. And it'll kind of let you know where it failed at, why it failed, and you can go back and resolve these things. So the problem is it doesn't fail gracefully. If I do something wrong, you can see here, I got all of these errors as I was trying to do weird things, and that's because, again, compiled languages, the setup has to be perfect. Everything's got to match. There are a lot of rules that you have to follow to be able to compile the code and to run it. And so what else did it say in this? Let me pull this back up. Let's break down the rest of the words in here. So that's interpreted. The assembler, let me make that a little larger. If I just doing the opposite and making it smaller, which is weird. Oh well. Okay, so yeah, assembly language varies for each individual computer. Again, we talked about that, different architectures, different operating systems. And then maybe we can actually go to Golang architecture. Maybe we can see the options that we have available to you. cool. And actually, I'll make this a little bit bigger here. And so you can see how we were AMD 64. There are these things, you know, for Android. The target would be ARM. And, you know, we've got all these different things. So we've got Linux, AMD 64, but we also have FreeBSD, which is another operating system. And so we have all these architectures. You know, we have Windows. So if you're building for a Windows host, you would need to modify your variables and modify your build target so that it is it is the proper one. So that could be a little annoying. Yeah, and again, it doesn't fail quite gracefully. It's kind of annoying. People kind of don't like this, that when they make mistakes, you've got to be so strict and stringent. But that is a compiled language, and this is part of the reason why people think compiled languages are harder to learn. I think they teach you a little bit more, but I do think, you know, when you're starting out, they're a little bit tough to learn because of how strict they are. So interpreted languages. So let's show this and maybe. Cool. So interpreted language, so I pulled this straight from, what's that thing called? From Wikipedia. An interpreted language is a type of programming language in which most of its implementations execute instructions directly and freely without previously compiling a program into machine language instructions. So we just talked about that. So interpreted languages don't pre-compile. They do not pre-compile any of the code. They do. It's a little bit of a misnomer there, but they do compile the code. They don't compile it into a machine language. They don't compile it into bytecode. But at runtime basically is compilation time. It compiles basically when you run the code. But yeah, so it doesn't do that beforehand. And the interpreter executes the program directly, translating each statement into a sequence of one or more subroutines, and then into another language, often machine code. So what happens to interpreted languages are you don't have to do this pre-compilation. You could run the code. The interpreter will do its best to spit out the result of the running code, and you'll get something out. So languages, again, we talked about some compiled languages being Go, C, C++, Java being one of the biggest ones, Rust, I believe. There's a bunch of them out there. Interpreted languages are probably the ones that most people are messing with currently. So things like JavaScript, things like Python. So HTML is more of it's a markup language, so it's not quite. I don't think it's actually interpreted or compiled. I actually don't think it counts as either. I don't think markup counts as either one of these. But if it did, it would definitely be an interpreted language and not a compiled language. But yeah, again, Ruby, Python, JavaScript being probably the biggest one out there. So these are the ones that you can kind of hop straight into. They're not as strict. So if I was to write some code right now in JavaScript and it didn't work, it wouldn't throw these errors because, one, I would have to run it first before I could do anything, and at the time of interpretation, it would do its best to figure out what's going on and to do things to kind of guess at what I wanted if I didn't give it explicit instructions. And so that's good and it's bad. Again, they're easier to hop into. I'm trying not to give too much information now because all this leads directly into the static versus dynamic typing, which we're about to get into. And I was trying to stay away from that in my explanations before I got too deep. But yeah, so again, most of the languages you know about, you probably deal with on a daily basis, are probably interpreted languages. And again, interpreted languages are good because all you need to run on any system is that interpreter. So things like Python. So if I type in Python here on the command line, it drops me into Python's interpreter. This is a space where I can type in Python code and it will spit things out as I do them. So if I say print hello, it'll go ahead and read the code that I just did and print it out because it does not have to pre-compile first. And I can just do, like 5 + 5, and it should give me 10. Cool. So it's interpreting the things that I put in, and it's returning me the results basically. But as long as any computer that any system that needs to run my Python software has the interpreter installed. So as long as it has the Python interpreter installed, it will run that. It will be able to run that code. So you don't have to build for different architectures like you do, or different targets like you do with a compiled language. But again, I said that compiled languages are really fast, and I guess computing is so fast now. Interpreted languages are very fast as well. But you know, when we're talking about something at scale, you know, something that needs to be done very quickly, compiled languages are much better for. They're also a lot safer. Again, because there's a lot of them for things. A lot of compiled languages are called statically typed, which we're about to get into. So that keeps you from having you know, type errors and things like that, because it's not doing any typecasting or any type inferencing, I should say. So yeah, so that's basically the difference between the two. Like for Go, I can't drop into any interpreter that's going to read my code. I'm kind of going to write my code. I've got to compile it. I've got to run it. That's what happens when I run that run up here. It's compiling it first, and unless everything's good, it will be fine. So if I type in something like print, and I do hello, and I don't put the in brace, it'll give me an error. It'll give me an error here and try to let me know what to do to fix it. But again, that happens at runtime rather than compilation time. Cool. So let's get into statically typed versus dynamically typed. So types. Types are very important in coding. And let's open up a new place. Let's get out of here and go into documents, and let's make a new directory called types, and let's just open up Visual Studio Code here. Cool. So types in programming. So these are things like these are things like strings. So strings are just a list of characters, basically. Characters being, you know, letters, numbers, as well as spaces, and symbols. And so let's do types.js. And so this is a string. So if I just do just all these letters here are what you call a string. So whenever you think of text, text is almost always a string. There are some variations there, but whenever you think of text, think string. That's what a string type is in coding. You also have numbers, so you have integers. So you can see how it's a different color here. So these text editors do a good job of using color to kind of tell you that this is different than this. And if I throw a 5 in here, it's yellow because this 5 is different from this 5. This 5 is of type string. This 5 is of type integer, which again is different from. It might not change colors, but if I do that, this is actually a different type than this, and so this is something called a float. This is something called an integer. In languages that are compiled, so if I open up a Go file and I do the same thing here, and I try to add like this to this, it will not work because these are of different types. So when we say statically typed versus dynamically typed, I know some people like to think about, you know, typing on a keyboard. No, they're talking about these types. There are tons of types. There are structs. There are all kinds of things. But these are kind of the basic types. They're Booleans. So if I type in true, or if I type in false, it's interesting they made those the same color as the integers, but that's fine, and the floats. But this is a different type. A Boolean is a different type than all the rest of these. Boolean being true, false. But yeah, so statically typed versus dynamically typed. Statically typed languages do something called type checking at the time of a compilation time, or runtime, because again, compilation happens there as well. But so if I go back into, let's just open up a quick Go file on the same thing. Let's do types.go. I have to specify when I make a variable. So let's go package main. So also again, these compiled languages take a little bit more setup, and I've got to have a main function here because that's what you have to have in in a compiled language, or at least in this compiled language, I've got to set up type. So let's say I want to make a variable called test. I have to specify what the type of this variable is going to be. So I can't just type var test. I've got to say that it's going to be a string, or I've got to say that it's going to be an integer, or that it's going to be a float. Why didn't that work? What, I gotta give it float 64? Yeah, I'm gonna give it float 32 or 64. But yeah, I've got to tell it what kind of integer that's going to be. Whereas in here, I can just do var test. I can just do var test. And again, so the language that I'm using over on the left, this is JavaScript. This is an interpreted language, and JavaScript is going to do its best to interpret these variables at runtime. So what happens is you can have some weird things happen. So if I say var test, I make var test appear. Actually, let's use let because it's better, and we should be using let. And so now I can say test is equal to 10. And then let's just console.log. Let's print out that variable. So it's console.log test. And I try to run this. And I go node types.js. Whoops. What happened here? Am I not in the right? Oh, cool. So I say node types.js, and it prints out 10. So I said test is equal to 10. I printed out 10, and that's what we got. So if I go here and I do var test, let's say I do var test equals string. First, let me just do var test with nothing there, and then I try to print this. And I try to print this. Automatically, I get this error saying unexpected new line, expecting a type here. And so this is that static typing. Your typing has to be static. It's got to know what types to expect, and you can't really change those things. It's looking for very specific things, and you can't just get away with doing nothing like that. So I can do, actually, it's kind of added in the same way. Let's set test equal to 10. Let's try that too. Save it again, and we still have the same error. If I can get back to problems, we still have this. It's expecting type. So I have to say it is of type integer. And I'll save that, and everything's good. And if I run this, type.go, if I get it, it prints out because I've told it what type to expect for test. And if I try to if I do something wrong, because this is actually compiling when I hit go run, it lets me know that I cannot use 10 as a type integer, because 10, it knows 10 is of type integer, but it knows I want it to be a string. I said there's going to be a string here, then I put an integer in here, and then it broke. So again, over here I showed you that we can make something a string by just throwing some quotes around it. So whenever you think of, whenever you see quotes, know that that's a string. If I hit save, this will work again, and it will print out the string 10. This is actually different from this. You can't tell it here in the output, but they are two different things. Cool. So let's go to how else can I show this? So also, let's say I wanted to do, let's say I had another function up here, func, I'll just call it my name, and I say it's going to take it's not going to take anything, but I actually have to give it a return value. So let's actually say it's going to take test. So let's say it's going to take X, it's just a placeholder. It's going to take a string. So I even have to tell it in the function what to expect as an input. So let's say this is going to take a string called X, and then I want it to output. Let's say I wanted to do some logic and return if it's true or false. And so I can say, actually, let's change this to an integer. Actually, I can do that. I can say it's going to take an integer called X, and let's change this to an integer. Let's take off these. So now that this is an integer, And I'm gonna say if x is greater than 0. I think I have to put that in parentheses, but I'm gonna say return. Well, my dog scared me real bad right there. I'll say return true, and then else we're just going to return false. Cool. So again, we talk about true false being what's called a Boolean value, and then down here let's just run. Let's format.println parent. We'll pass in test as our input, and let's go ahead and run this. Cool. So I put in basically what I did here is I'm passing in this value of test, which is 10. I'm passing it into this up here. Again, it has to be an integer. If I change the type of this, it will not work. So if I say the type is string, this will fail. And it will fail again because it compiled and it knows it runs through all the code, and when it's trying to convert it into that bytecode, it's saying, hey, this is not working out for me. I don't think this is going to work, and it lets me know what's going on here. Over here, I can kind of do whatever I want. Even if I change that, I can do, let's see. Maybe a better example would have been, I have test equals 10 there. What if I did console.log test here again, and then what if I did now test is equal to hello. So this is of type integer, this is of type string. Over here, let's try to do the same thing over here. Let's actually delete this. Let's do that. Let's format.print. We'll print test first. And then let's try setting test equal to the string hello. And then let's copy this line and see what happens when we run each of these. What do you think is going to happen when we run this? So we'll go ahead and run this first. We will run node types.js. And so this should, we set a variable called test. We set it equal to the integer 10. We print it. We're going to print out that integer. Then we're going to try to change the value of this variable. So variables are something that can be changed, and we're going to try to change it to the string and print it out again. But what about type inference in Go? There is no type inference in Go. Zero type inference in Go. It's a statically typed language, so you need to always tell it what the types are going to be, what to expect. It won't try to infer type at all. JavaScript, on the other hand, will, and that's what I'm going to show you right now. Also, the types can't change in Go. We'll see shortly that the types can't change, whereas in a dynamically typed language, the types can change, like here. Do I have much website experience? I do have a decent amount of website experience. I'm actually currently working on a project where I write a bit of React. I've done plenty of HTML and CSS as well. Yeah, I do have website experience. I have a lot more experience doing more automation things, a lot of scripting, a lot of background jobs, building those things out, a lot of infrastructure automation. That's kind of what I do as a DevOps engineer, a lot of automating AWS, doing infrastructure as code and things like that. It's not a ton. I don't have a ton of web experience, but I have a pretty good amount of web experience, enough to where I can absolutely make my own websites. I'm working on some projects now. I've helped people make websites, etc. And we'll be doing some web development on here as well, because I think that's something that most people want to learn here. So let's go ahead and run this, and let's see what we get. We see that it printed out 10 here, and then it printed out hello. So we could change the type here because this is a dynamically typed language. We were able to change the type from an integer to a string. But if we try to do the same thing here, it's already giving us a problem, an error. Cannot use hello type string as type int in assignment. So basically, because we had to set the type up here, the variable test must be an integer and not a string, so it's not going to work, not going to compile, not going to let us run this code. But we could do something like this. That's also a string. First statement must be first. Package. That's fine. That's fine. This should still run. This is actually. Let me actually see if that's a problem. Go run. Yeah, it still runs. That's actually even though there's an error, it's just because there's other things in this file structure that are not a Go package. We can ignore that. So this prints, but this actually won't print. This actually shouldn't happen. So if I do this, again, I talked about how integers were not the same thing. Even though they're both numbers, they're not the same thing. Integers are not the same thing as floats, as decimals. So if I try to run it, it's failed. Yeah, it'll fail because these are different types. Cool. So that's how static versus dynamic typing is. This will do this for your whole project. So there are a lot of times in here where, like, because I can do this dynamic stuff here, and let's say I set test equal to 10 here, but maybe later in my code, I accidentally set another variable or set test equal to 15, the string instead. This will work. It will work, but it may cause some big error down the line, and it becomes difficult to debug. So it's actually, I find it difficult to debug dynamically typed languages. It's a little bit, I do think it's a little bit, I think because they are easier to mess around with, I think it's easier to resolve the problem, but I think it's a lot easier to find the problem in a compiled language. But you can also do things like this because the types don't matter. You can do things like this, not don't matter, but because it's dynamically typed, I can do test, and I don't know, I can do help, and then I can add these together. Even though one's a number and one's a string, I can do this. And actually, let's remove this. We don't need this here. Let's clear this, rerun it. And you can see how all it did was just add the number 10 to the string 15, and we have this weird thing. And so now you can see how, like, if you had a crazy program, let's say you were a banking company, you had a lot of crazy things running in the background, you can see how a simple type error like this could really destroy your systems if you were trying to add up some numbers or do some number crunching, and someone accidentally all they would have to do is throw some what are these some quotes around this, single quotes or double quotes, and it could cause real problems, and it's kind of hard to find that sometimes. But in Go, that's just not that's not a thing at all. You definitely cannot you definitely can't do that. Even if I do this, even if I do var help and set that to a string, so that I can actually know I'm instantiating those properly. If I do test plus help, this will fail because it's a mismatch type. You can't add these mismatch types together. Yeah, and that's why. So this is very strict. This is static typing is also referred to as strict typing. It's very strict in what you can do. And dynamic typing is a lot more loose in what you can do. Yeah, and what it allows you to do. So cool. That is, that's static versus dynamic typing. That's compiled versus interpreted languages. Definitely, if this is your very first time, coding, or it's the very first time you're trying to learn how to code, I'd recommend getting with an interpreted language first. So again, something like Python. Python is what I absolutely recommend to learn first if you are learning on your own. That's the big caveat here. If you're going to be self-taught, I'd say dive into Python or JavaScript first. And then I absolutely recommend learning once you've got the basics down, once you kind of have a good understanding of kind of some of the core concepts, so that it's not so overwhelming, I do recommend learning a compiled language, a compiled statically typed language, because there are some static typed interpreted languages. So JavaScript has something Microsoft actually created, something called TypeScript, which is a statically typed branch or framework around JavaScript. So if you do want to mess around if you know JavaScript and you want to kind of mess with the idea of a static type language, definitely check out TypeScript. because you can do that. But I no, after you kind of get comfortable with one of these, I'd recommend going with a compiled language to kind of understand what you're doing a little bit more. I think it provides a lot more computer science concepts to you. I think it makes you a better programmer. But if you are going for a structured learning course, and you have a teacher, you have some guidance, I'd recommend it's so much easier to go from a compiled language, a compiled statically typed language, to an interpreted dynamically typed language. It's so easy to make that switch. You've already jumped all the very difficult hurdles. So if you've got that structure, if you've got that in place, I'd recommend going from compiled to interpreted, and if you're learning on your own, I recommend going from interpreted to compiled. So now let's get into the tools that you have at your disposal to do this stuff. You see me on here hop into Visual Studio Code here. A lot of my live streams, I've hopped directly, into something called Vim, and I might do a little bit of, the code editing in here, inside of a terminal. But let's talk about that, and let's talk about what you have available to you. So there are two, I guess, things you can use to write and to edit code. So one is called an IDE. So IDE stands for Integrated Development Environment. So what is an IDE? Let's see if there's a good description or definition on here of what it is. One that's not too wordy. It's pretty wordy. Let's see what it says. A software suite that consolidates basic tools required to write and test software. That's probably a good enough description right here. So an integrated development environment is used for a single language at a time. And what it does is it provides you all of the tools, all of the features, suites of things that you can use to be able to develop code quickly. Hey I-95, hello, welcome to the stream. So let's move this off because that was a little bit of a weird inception. But some of the ones you may have heard of are things like, let's pull some of them up. So Eclipse. So if you're learning Java, a lot of computer science students learn Java in school. So this is probably the first one people have had. If you've had experience with an IDE, Eclipse is probably the one. So Eclipse is pretty cool for Java. It's got a lot of plugins, got a lot of features and things that make it very easy to get up and running on a Java project. It's been around for a long time. It's super mature. But yeah, again, it's there are plugins for other languages, but it is made for Java. There are a few others. There's some was it NetBeans is a free one, which is an IDE. This is like a web development IDE. And again, so these integrated development environments, there are, and compared to what I'm gonna show you later with text editors or code editors, they're heavy. They're slow to open, but that's because of all of the features that they have, and all of the they're doing a lot of analysis on your project files, on your code. But again, they do provide a lot of support, a lot of help. If you are working again in a single language, they can be very beneficial in helping you work faster. They give you debugging tools and things like that are usually pretty impressive. There's a company called JetBrains. If anyone's in school, if you have a .edu address, I definitely recommend checking out JetBrains. JetBrains makes tons of IDEs, so they have one for almost every popular language. And the problem with this is they do cost money. If you have a .edu address, you can get these for free a year at a time. So definitely sign up for this. Definitely check them out. So they have ones. This one's for Java. PyCharm is for Python. WebStorm. If you're doing JavaScript, definitely check out WebStorm. I've heard a lot of web developers who love WebStorm. You know, you got it for everything. You got it for PHP, C Sharp, C. You know, they've got RubyMine, which is pretty popular. I have messed with, so this is one of their newest ones. This is Golang for the Golang language. You know, I'm a fan of Golang myself. And what Golang is, the Golang is pretty cool. I messed with it. It does have tons of features, which is super nice. Again, but it can be a little bit overwhelming at first to kind of get a project up and started. You know, most of them, when you spin them up, you've got to kind of point to your executable for that language, and you've got to set up a workspace and things like that, which can be, you know, if it's your first time hopping in, it can be a little bit overwhelming. But again, very powerful as well. There's a kind of a high learning curve to IDEs as well. They've got a lot of shortcuts and things. For them to be valuable, you do need to take the time to learn the tools that they do provide for you, or else they're not all that valuable until you take the time to learn what they can do for you. But the reward is high. You know, a big high learning curve, but the reward is very high for doing so. And so that's an IDE. What I would say that what probably most people use. Actually, I wouldn't even say, I don't want to say most, because there are things like, actually, I didn't talk about probably the biggest and probably the best one, which is Visual Studio. And that's mostly because people don't like Microsoft, even though they should give Microsoft a chance. But Visual Studio is probably the best IDE out there. This is for, if you're working on any .NET stuff, anything in the Microsoft wheelhouse, this deals with. Actually, there's probably plugins for other things. So, you know, if you're doing C Sharp, all kinds of stuff, any .NET development, you can do. It looks like you can use Visual Studio App Center. So I guess there's other ways you can get Objective-C and Swift and some other stuff in here. But yeah, this is probably one of the best. Again, this is also not free. They do have a community edition, which is free, but this is one of the better ones. It's very heavy. It's a big download. But don't get this confused with Visual Studio Code, the thing that I'm using. We'll talk about that in a second. They're not the same thing. Visual Studio and Visual Studio Code are not the same thing. People always get that mixed up. But they're not the same thing. Those are probably all the IDEs you need to know about. Text editors. Let's go through those. So we talked about Visual Studio. Let's go straight into Visual Studio Code. So Visual Studio Code, let's talk about what text editors are first. So text editors are, they are exactly that. They are programs intended just for you to edit code on, to edit text on. Actually very similar to something like Microsoft Word, which gives you the ability to edit text, as well as some extra features for you to be able to develop, to be able to manage and change text faster. So things like, you know, finding and replacing, a lot of tools things like that. They've got some GitHub integrations, etc. So code editors they're not as heavy. They don't have as much tooling built around them. They're pretty fast, pretty flexible. You can kind of design them for however you need. So most of them have some kind of plugin or extension structure, where people can kind of develop extensions or plugins as needed, to kind of support the different things. So you can kind of see an image here. For this a little larger, you can see here that they're looking at extensions here, and they have one for C Sharp and Python and a debugger for Chrome, and they have one for Go here and ESLint. So you can kind of make most text editors, you can kind of make them what you want. And actually, because of how far technology's come, the gap between what an IDE is and what a text editor, code editor is, actually, like, it's shrinking. Like, especially with Visual Studio Code, you can essentially get IDE functionality out of this if you set it up properly. But again, IDEs have those things kind of right out of the box. So, good thing about text editors, they're usually available for all platforms. So this comes on Linux, Windows, and Mac OS, which is pretty cool. This is probably the most popular text editor out right now. It's actually pretty new. Let's see when this came out. So Visual Studio Code release date. It wasn't that long ago. Initial release was in 2015. So that really wasn't that long ago. And it's kind of taken off. Microsoft puts out very frequent updates for this. They support it very heavily. It's heavily community supported as well. This is the text editor that I would recommend. I think it has the easiest to use interface. Let me open up one. It's a pretty simple interface, pretty simple. See, when it opens up for me, it's got all this stuff open because I've done a bunch of stuff on this channel. But it's a pretty, let's close it all. I don't need any of this stuff. No save. It's got a pretty simple interface. It gives you just a place for you to edit code. It's got your files listed here on the left. And you click on it, opens up here on the right. You can do cool things like splitting the screen so I can see my code side by side, kind of compare and things like that. It's got, syntax highlighting so you can see how all the different things are different colors. That helps you visually be able to see things. These are things that only IDEs used to have. But I mean, this stuff has been around for a while for text editors. But, I've got search functionality here. I have Git functionality. So if I want to, push this stuff up to GitHub, I can do it without having to know how to do it from the command line or using any type of third-party app. If I want to install an extension, I can just do that here and search for what I want and go ahead and install that and get and add functionality as I need it. That's such VS Code. Again, probably one of the most popular ones. It's pretty easy to install. It's free. It'll always be free. It's open source. You can download it here if you'd like. Yeah, and so let's go into some of the other popular ones. So Atom is one that was built by GitHub. Actually, do I have it installed here? I don't have it installed. Yeah, but Atom is a pretty good looking text editor. Has a lot of themes. Also has tons of packages. I used Atom for a while. The biggest problem with Atom is it's slow. It does not handle large files very well. The same way I said IDEs are kind of slow. Atom is a slow text editor. It takes a long time to open up big files. It's kind of a computer hog a little bit because it's built from JavaScript. It is an Electron app. So is VS Code. But I don't know what kind of magic Microsoft does to make it faster. But Atom is very slow. Very slow to open up large files. And for a lot of work that I do, I open up large files very often. So I kind of moved away from that. But it's still very heavily used. It's a hugely used IDE. And I would definitely recommend checking it out. Again, all these are free. So take your time. Evaluate them. See which ones you like. See which one has a better user experience for you. See which one fits your flow better. Again, I think VS Code, people love it because it's so easy to add plugins and things like that. Atom is as well, but not quite as easy. It's got a little bit different layout, but still for the most part, it's the same. It has really good GitHub integration because, again, it was built by the people at GitHub. It's a great text editor for you to check out. Probably, maybe 5 years ago, this is the one that everyone was using. So Atom needs WebAssembly to beef up the speed of the future. I 100% agree. It needs something. I don't know if WebAssembly is the thing that will come and save it, but it definitely needs something to come in and speed it up. I find it very difficult to work with for a lot of the things that I do. Cool. So we have Sublime Text here. This was probably the default text editor of choice for tons of people. Probably just 5 years ago. This was probably the one you probably went to. It might have been Sublime Text 2. But yeah, Sublime Text 3. It's fast. It's free-ish. So it has a trial period, but the trial period never ends. So vast majority of people are using it for free. It doesn't, when that time is up, it doesn't give you, you don't lose any functionality, which is nice. But it will every now and then when you save some files, it'll say, hey, you've been evaluating this. Do you want to buy it? And you kind of got to click the box and say, no, I don't want to buy it. I actually do own this. I've purchased a license. The license is like $80. It's $80. Worth it though. If you're, it's really a cheap price if you are doing, if you're using it to code. It also has a pretty robust package solution, but it is difficult in comparison to install things in the package manager. The package manager is not intuitive at all. but it is very quick. It's a great text editor. I definitely recommend checking it out as well. Yes. So, for those of you who don't know what Electron is a JavaScript framework that allows you to make desktop applications. One of the side effects of that, JavaScript is fast, but it's not that fast, and Electron apps are notoriously slow on desktops. And yeah, VS Code is really quick. I don't know how they did it, but they need to apply some of that to the rest of their code base, to the rest of their applications. They need to apply some of that love and all that research that they found in that engineering, because it is very fast. But yeah, so these are probably the three biggest ones. We're definitely going to dive into some more in a second, but Visual Studio Code, Atom, Sublime Text, definitely take some time to check those out, evaluate them. Learn what you can about them. See if they fit your workflow. Again, it's different for everyone. Find the one that works for you. Another one is Notepad Plus. So you could so you could, if you're on Windows, or I don't know what the Mac equivalent is, but you could write code right here in Notepad, and I could do console.log, and I could console.log hello world. And just like that, I've written a Hello World app, my very first JavaScript program, and I can save it, and I will be able to run this. Not in Notepad, but I will be able to run this out of my console. I know that's really small, you can't see it, but again, in these text editors, you are just editing text, so you can do it. You could do it in Microsoft Word if you wanted. If Microsoft Word lets you save in non-Word format documents. I don't know. I don't really write documents anymore. I use Google Docs for all that now, but you can't, but you can see here how you don't get all the cool things like syntax highlighting, and I can't see, if I wrote a bunch of code here, I couldn't see, where my functions were defined and things like that, which sucks. So it will be very slow to do so. But one of the big ones is, I don't think I have it. Yeah, I don't have it installed here. But let's go here, Notepad. You ever seen Notepad Plus? This is a very popular one as well. Tons of people use this. Yeah, Notepad Plus is the first editor a lot of people used. It's a good editor. It really is. It's a good. If I was in Windows more and I was doing quick edits, I would probably use Notepad Plus for a lot of those things. But yeah, it's lightweight, again, free. You can do a lot of development in Notepad Plus. Definitely check out these three first. Notepad Plus doesn't have quite the extensive features that these have, but it is for sure a valuable text editor. There's a few other ones. There's one called Brackets for web development. Yes, there's Brackets for web development. This is mostly for I think it's just HTML, CSS, and JavaScript. Maybe there's plugins for other things. I don't really know. I know Brackets is one. What else do I know about? We already did NetBeans. That was an IDE. Yeah, so check those out. But again, these code editors don't quite have the functionality of an IDE. They don't have, all of those things that are necessary to run and to debug programs. I mean, they do. They do have all those things, but they don't have quite as many features. But the learning curve is a lot lower, and you can modify these to work for how you want to work with them. With the crowds, Notepad, and Emacs and code editor, yeah, and code editor for Java, yeah. So we won't talk about Emacs, but that's very good. We will talk about Vim though. So let me do that now. So Vim is my code editor of choice, probably in when I'm making code changes, probably 70% of the time. I'm in an application called Vim. Whoops. So Vim is a text editor that lives inside of a terminal. So when you log into, I've done a lot of server administration and things like that. And so when you log into a server and you need to modify files, you don't have all this beautiful stuff. You get dropped into a text screen like this, and you must make changes yourself. Actually, let me go to the one that's in here because the text is already larger. But what do you want to do when you need to make changes? You go into Vim, and Vim allows you to edit them. Emacs is something we talked about Emacs before. Skull Crusher brought it up. It is another editor inside of the terminal. There's a big war over Vim or Emacs. Any sane person would say Vim, but there are people who like Emacs a little bit more. So I brought Emacs. This is pretty cool. That's great. So Emacs. So if you go to emacs.dev, it redirects to vim.org. Again, Vim is great. Vim is one of those things where it's a text editor. It's just like these. The plugin library is very extensive. Actually, let's pull this up. It's very extensive. You can get all of the I have the code highlighting here for Golang, and you can get all of those things. Actually, do I have like nerd tree and stuff? No, I don't have. Actually, do I? I don't have like nerd tree and things, but there's a lot of plugins and things. It's kind of hard to deal with them if you're not super comfortable with what you're doing. But Vim is really nice. It's what's called a modal editor, so the learning curve to use it is very high. I think one of the most searched questions on like Stack Overflow is how to exit Vim. Let's see. Yeah, Stack Overflow helping 1 million developers exit Vim. It's once you get into Vim, it's very difficult to. Well, it's not difficult to, but if you're unfamiliar with it, it is very difficult to exit Vim. Again, because it's modal, so people get in, they try to start typing. So right now, if I just start typing, nothing really. Well, I pressed the button that allowed me to type, but let's undo that. Until when we first get in, it lets me know right here that I'm in normal mode. Before you can really start typing, you've got to get into something called insert mode. So I hit I, and now I'm in insert mode, and now I can make code changes. Now I can make code changes, but to get out of it, you've got to take it into command mode. So you've got to give it a colon there, and then so if I want to save it, I hit a W. So W stands for write, and that writes my file. And to quit, you have to hit Q. But if I hadn't saved it and I tried to quit, it would fail, and people didn't know what to do, and you got to string the commands together. So usually to get out, you got to do :WQ. I do Shift ZZ. People don't really know about that. I don't do :WQ. But Vim is my go-to because I do a lot of things from the command line. Vim is my go-to editor. And let's see. Let's maybe go to. Let's show you guys something cool. Actually, it's not even on here, is it? It's not on here. So let's maybe go into one of our let's say JavaScript and collapse conjecture. Yeah, and so you get in, you can see a file that's a little bit longer, but you can kind of go in, and to copy paste, you've got to go into a visual editor. So I hit V, and you can see the block change to visual, and I can grab, these lines I want, and to copy it, I have to, I've got to press Y to yank it, and you can see 5 lines yanked. And so you can see here, I'm saying all these shortcuts and things. And if I want to paste it, let's say if I want to go down here, I have to go I to get back into editor mode. Actually, I don't want to be in editor mode. I hit P, and it'll paste everything down here. And if I want to delete all these lines, I can hit double D, and it'll delete lines. But you can see here how, and I hit Shift ZZ, it'll save and exit. But you can see how that's really complicated, and that's something that I've learned over time, and that I have muscle memory that helps me get through that. But Vim is powerful. Vim is very powerful. If you can get your workflow with Vim, if you learn the commands, if you learn the shortcuts, your workflow can be so fast. I've seen people who are amazing with Vim just do things so quickly. And be able to modify code and change code and write code so fast. It is a valuable thing to learn, I think, and to check out. People use Vim to write code and a GUI editor to recode. Absolutely. I almost read exclusively in Vim when I need to read people's code. People caught up in Git commits since it defaults to Vim. That's true. When you try to, actually, I don't think it always, I think on a lot of computers it does. I don't think it always does. I think if you're on Linux, actually, it'll default to something called Nano. Nano is a much simpler text editor. You can just go in and type and exit and save. If I want to exit, I canceled. What happened? Now I'm stuck. I'll save that. Oh, I didn't give it a name. I'll save it, and I'll call it. Save it. I'll call it test.txt. And I've got a file here. If I take a look, I've got this test.txt which I've created. So if you're trying to do, if you are commit messages, or sometimes if you're doing if you're handling a merge conflict and Git, it'll drop you into Vim, or it'll drop you into Nano, which is really annoying, and people get stuck and can't really finish pushing their code, which is crazy. But super understandable. Again, Vim is pretty tricky. Have you been watching Microsoft build a lot? Yes, I have absolutely been watching Microsoft build. There are a lot of cool things coming out of the Windows subsystem for Linux. So if you saw, so right here, I'm in a Linux, this is a Linux VM right here that you guys are seeing. If I'll minimize that, now we're on my Windows desktop here, and we can get this off. This that you're actually seeing, let's open up. Windows now has, they have something called the Windows subsystem for Linux. Wow, that's really small. But if I type in bash, let me see here. I already have it installed, but why is it not? It's not showing me. Okay, cool. Let's exit out of this. But now you have the ability to run Linux inside of Windows, or Linux command line that's interoperable with your things in Windows. So from here, you know, I can see my Windows file structure, and I could go into, you can't see this, it's too small, I don't know how to make this bigger, but right now I'm going into a directory that's on my Windows machine, and let me take a look at it. Let's take a look at documents. Let's go back one. Ugh, I hate that noise, it's really annoying. Oh man, that's so annoying. I need to disable that. And right here, I'm on my Windows machine, and I'm in my Linux container. I'm in my Windows subsystem for Linux. And what I can do here is I can do code dot, and this will open up. This actually opens up a Windows program from inside of my Windows subsystem for Linux. So I'm in Linux, and I can manage and check out things that are on my Windows side of things, which is pretty cool. It's actually pretty epic, and that's the reason I'm still sticking so heavily with Windows. I like the direction they're going, and companies who are moving in that right direction like to invest my money into in buying their products, because I don't know, Windows is a good thing, and I like companies who kind of listen to, who eventually, even though it took them a long time, who start listening to their audience. You know, developers started a giant exodus from Windows because it's very difficult to develop software on their platform, and they've listened, and they're making a lot of changes to work better. Cool. I recently started startup Google search without, the Google does do a lot of evil tracking. There's also DuckDuckGo, if you're looking for something else that doesn't track you when you search. Privacy Simplified. There's also some cool browsers if you're someone who is security focused. Check out the Brave browser. It's secure, it's private. I think it has automatic ad blocking, automatic like tracking blocking, and things like that. So definitely check that out if you want to check that out. But yeah, that editor ding, I'll disable it. I do know how to disable it. I just don't. I actually don't do any like. I've actually fell in love with Amazon's Cloud9. So on my laptop, I run a Linux laptop. I'll do all my work on there, like any of my coding on there. And if I need to code on this desktop, I'll log into Amazon and log into my little workspace there that I have, so I don't have to deal with setting things up right now. And because I kind of want to keep this just for gaming and for editing. You can see over here that I do play some games. I got Borderlands set up here, play Overwatch, that's up here, and Apex Legends I still play a little bit of. But that's why I kind of also stick with Windows. Windows does everything I want to do, because I'm also going to be editing videos for YouTube, for the Mastermind channel, and Linux is not good at video editing, and I just refuse to pay Mac money for what you get, and I won't be able to play games anymore, and I like to play games in my downtime. How to beat the ding? So yes, I will find a way to send you the information on how to disable the dings for Windows Substance for Linux. I don't know if you can do it on command prompt though. Like I don't know if you can do it on the Windows side of things, but you can do it in Linux for sure. Is Tor good as a private browser? So Tor is yes. So let me answer the question first. Yes, it is good for a private browser, but Tor does not surf the traditional internet. Tor searches what's called the deep web or the dark web, and it operates a little bit differently from your normal internet. So at least from when I use Tor, maybe Tor has been updated. To people who aren't familiar with Tor, it is a browser again used to search the dark web. Maybe it's been updated. I haven't used it in years, so maybe you can search the normal internet. If you can, I'm sure it's good for this. But Tor, when I was using it, was deep web and dark web only. But again, that was a long time ago. So maybe it is. Maybe check it out. It looks like it is. It looks like it is a browser that you can use to keep your anonymity intact. So definitely like try that out and definitely let me know how it is. Because again, it's been forever since I've used it. I use bash command probably when you can't even turn on the. That's what I'm saying. Yeah, that's true. VPN is better than for normal use. VPN for what is better than for normal use? Actually, I used to be so heavily into all this stuff, all this private browsing, all of the VPNs, and I had seed boxes and all kinds of stuff. And now I don't know. I've kind of been living the YOLO life. I use a Google Pixel, so I feel like Google's they know everything they need to know about me, which kind of sucks. But I have considered hopping into Brave. There was a period of time where I was like open source software only, like private software, and then grabbing open source software only. And I lived that life for a little while. I may go back to it actually. I may go back to it only because of if I can figure out how to video edit like consistently and well in Linux, I'll go back to it. I need to not play as many games, so it'd be nice to have to switch fully back into Linux and stop me from playing games so I could get more stuff done. But as of right now, I don't know, man. Windows is nice. If no one's ever used. One thing I learned about Windows is that most people who hate Windows have only ever used $300 HP laptops. Do yourself a favor and spend some money, just like you would spend on a MacBook. Go spend $1,400 plus on a laptop, on a Windows laptop. Grab a Surface laptop or Surface Book, and I think you'll be impressed. I think we've kind of come to the time in history when the hardware. Just like phones, it'll do what you want it to do. It's kind of become preference. It's not like unless you're in crazy sites, you're not going to get a bunch of viruses and things like that. It's really weird. But yeah, Pop OS, yes. So I told you I use a laptop. So there's a company called System 76. I always shout them out. I'm not sponsored by them or anything, but System 76. They made a Linux distro called Pop OS. It's based off of the popular language Ubuntu, or it's Debian based, but it's Ubuntu based. Not language, distribution. And so it works really well, especially for. It's notoriously difficult for things like to get drivers working for things like video cards, and they kind of have an in-house team that manages firmware and stuff, and so all the stuff works. So I actually own their Galgo Pro laptop, a pretty beefed up one, and when I tell you I've dealt with Linux for a long time, and you always have issues with sound cards and Wi-Fi cards and Bluetooth. I have no issues with it. It works flawlessly. So I may install Pop OS on here, and I may actually evaluate one of their desktops. So I have a custom built desktop. But I may if I have some issues, I may evaluate there since the software is built to work on their desktops. I might check it out. We'll see. We'll see what happens. Maybe they'll send me one. Maybe that would be great. But yeah, that's kind of all for tonight. This got deep into a conversation about all the different options that you have, and that's pretty important. I think that's what people need to. I think it can be overwhelming for some people in the beginning, finding out, all the options they have available to them. That's why I wanted to kind of introduce you all to some of the things that that you could use, some of the IDEs, some of the tools you could use, some of the text editors that you could use to kind of get started. Talk about some of the more popular ones, and give you a chance to evaluate for yourself. But at the same time, you can also just grab one of them. Grab Visual Studio Code, grab Sublime, and make it do what you want it to do. They'll all do what you want to do. If you want to just get started and start learning things, just grab one, pick one, download it, get going, and start learning the stuff. But once you get into it, take the time. Exercise your choice. Your exercise your right to choice, and see what works well for you. Like I always tell people, I talk to people all the time, and they do something and they think it's just fine, and there are a lot of things that'll just work fine for you, but there are other options that'll work amazing for you, and I encourage everyone to kind of get out and start to understand. You'll also start learning a lot more about computers, a lot more about technology, as you kind of evaluate these things. So definitely check it out. So does Pop! OS support running as a live CD? Yes. Yes, Pop! OS does support running as a live CD. It is not required to be installed. You could throw it onto a hard drive. And so that question, for anyone who doesn't know, download when you if you want to evaluate a Linux distribution, you can either download one of these two programs, is what I generally advise. So you'll download something like, let's open up Pop! OS really quick, and you'll download it. It'll download into something called an ISO file. You take that ISO file, which is designed to be burned to a disk, and you can download a program called Etcher or Rufus, and you can burn basically that ISO image to a thumb drive. So I got this thumb drive here. I can plug this into my computer right now, and download one of these programs and install an operating system on it. And actually, this one actually does have Linux installed on it. And then what you can do is restart your computer, have it boot up from that disk, from that USB stick, and you can evaluate Linux. And maybe we'll try to do that one day. Maybe I'll set up an external camera and show you how that's done. But you can kind of mess around with Linux, evaluate it without having to actually install it on your computer. Again, there are caveats to that. You can do most things. You can't do everything. Everything won't be saved. You install applications and things like that. It'll be temporary. But it is a way for you to evaluate Linux on your computer to see what works, what doesn't. You can find out, if your hardware works with that Linux distribution. So it's pretty cool. Most Linux distributions nowadays can run as a live CD. Yep. Or you can just mount the ISO into VirtualBox for Windows 10. I use VirtualBox. What I was running before was a virtual machine. Actually, I'm still running it. But you may not have a computer that's beefy enough. That's what I like. Some people don't have a computer that's beefy enough. I mean, my computer is pretty beefy. I've got 8 core, 16 threads. I got 32 gigs of RAM. I've got a lot of extra space here to be able to run extra things. If your computer's not powerful enough, the live CD may be your option. But VirtualBox is certainly something I would mess around with. I think that video is definitely on YouTube, or you can find a video on YouTube, or you go to my channel. I think I uploaded the one where we installed Linux inside of a VirtualBox in a virtual machine here, so you can try to do that yourself as well. Yeah, you can make a bootable disk in Linux using the dd command. Actually, this Rufus program here, you can actually burn it using dd as well. I forgot what the dd command in Linux stands for. What does it stand for? It doesn't tell you, but yeah, you can use it for to convert and copy files, but you can use it to burn disks and then copy files to a disk. Which is pretty cool. It's also a very dangerous command. I've seen people destroy all their stuff with it, but definitely something to mess with. Cool. Yeah, so I think that's it for tonight. Definitely take the time to test some of those things out. If you have questions, reach out to me if you have questions on, like, if you're working on a specific language, on which editor may be best for you. you can kind of check out the plugins that are available for them, see what people are saying about it. But yeah, they should all basically work for the things that you want to do. Again, if you're downloading an IDE, most IDEs for the most part are language specific. A lot of them have plugins too where you can add support for others, but most of them are language specific. So keep an eye out for that. Make sure you're downloading the right one. If you're messing around with multiple languages, text editor is probably the one you want to go with. Other than that, well, first off, let me say that Edge is not that bad. I don't use it, but it's not that bad. Internet Explorer is terrible. Edge will be changing soon, though. They're abandoning it, and using a Chromium backend, so it will be very Chrome-like probably in the future. Firefox is cool too. I like Firefox. I use it for a lot of things, but Chrome still has my heart. Yeah, Chrome's got my heart. Well, for a while, honestly. But maybe I'll make the switch. Maybe I'll see what my life is like if I get to some of these other things. But Windows 11 to run Linux kernel. Google does own me. I do know. Like, I'm not an uninformed consumer. I 100% know that right now Google owns me. I will make an effort to change that one day. It may be too late already. I kind of gave in a little bit earlier than I should have, but I do know that at the very least, I know Google does own me, and I'm. It both hurts me to say that, and I'm both okay with it at the same time. But yeah, until I'm trying to think what the plans are for Wednesday. We got pretty far into the Linux stuff. I don't know. I'll figure something out for Wednesday. Probably do something cool. Maybe use some of the Linux stuff that we've learned to do a little project. Maybe we'll start a little workshop or something where we actually start building some cool things that take a few streams to build out. Maybe something we can all contribute to as well. Yeah, thanks for tuning in. Thanks for the banter. Thanks for the conversation as usual. I know I missed last week, but I'm gonna try to be as consistent as possible from now on. Again, Tuesdays and Mondays and Wednesdays. I might even throw in one more day per week. But yeah, I'll let you know about that. So hopefully, definitely tune back in on Wednesday. Appreciate you all. I'll see you then.